Ever wondered how AI can turn a video of a dog into a super detailed 3D model? Let's dive into how the 4D-Animal model does this, and why it's a game changer. Here's the problem. Traditional 3D modeling from videos relies on sparse keypoints, those manually placed markers on an animal's body, like a skeleton. But this approach is time-consuming, error-prone, and limited. It's like trying to draw a portrait by only marking the eyes and nose, missing all the details in between. Enter 4D-Animal. This system skips the manual markers entirely. Instead, it uses dense features, a rich web of visual clues from every pixel in a video. Imagine your computer seeing the entire animal, not just a few dots. By mapping these clues to a 3D model called SMAL, a digital skeleton for animals, it reconstructs the animal's shape with incredible precision. Here's the magic. 4D-Animal uses a hierarchical alignment strategy. Think of it like solving a puzzle with layers. First, it matches the animal's overall shape to ensure it looks right from a distance. Then it focuses on finer details, like the head, body, and legs, using semantic masks, digital outlines of body parts. Finally, it tracks individual pixels across frames to keep the animation smooth, like following a dog's tail as it wags. But how does it handle the messy real-world data? The model uses vertex offsets, tiny shape adjustments that nudge a 3D mesh to match the dog's silhouette. To avoid getting stuck on blurry or noisy video frames, researchers gave it priority settings called loss weights. They started by focusing on the big picture, the overall shape, then gradually dialed down details like fur strands. Why? To prevent overfitting. Instead, they ramped up the temporal consistency loss, which teaches the model to move smoothly across frames. It's like training a dog to run, not just pose, no jerky animations here. Testing this system meant running it through 10,000 training rounds, like an AI marathon. Early on, it focused on the dog's shape, then shifted to smooth motion. The results? It started slightly behind other models like avatars, but quickly caught up, hitting target accuracy faster. Efficiency? Check. What really sets 4D-Animal apart? It doesn't need sparse keypoints. Instead, it uses that hierarchical alignment strategy, blending silhouette shapes, texture details, and motion over time. This makes it super robust, even when labels are missing. And here's the kicker. When tested on cat videos using a dog template, it still worked. The core techniques, tracking motion, aligning 2D to 3D, are universal. This isn't just for dogs, it's a flexible framework for any animal. But the real breakthrough? This model doesn't just compete, it upgrades existing systems. When tested against top models like SF3D and TriplaneGaussian, they struggled with real-world animal videos. But by fine-tuning them with 4D-Animal's results, they unlocked new potential. It's like giving a high-performance engine a turbo boost. So what does this mean? We're not just building better 3D models, we're bridging the gap between synthetic data and real-world complexity. This could be a foundation for future innovations, blending the best of both worlds. Next time you see a 3D animal model, you'll know there's a whole lot of smart AI behind it. Thanks for watching. If you want to see how this tech works in action, hit subscribe. There's more where this came from. And don't forget to check the description for links to the research paper and code. Until next time, keep exploring.